So today I want to give you a little bit of demo of a VDAS system. It's very easy. You need to turn the system on. There's always a manual next to it which you can use to access things that you need. This is a user manual. It talks how to turn the system on, where the key components and everything. It talks about the experiments as well. And in this course, we normally do the experiments, which are here. And then there's experiment results, and there's also calculation sheets like these where you need readings from the results in order to calculate those things. But first things first, you need to turn the system on. That's how you turn the system. You need to do it 90 degrees down, and it turns on. There's an inlet, which is at the bottom. There are chillers and all those other things that you can see. You need to speed up the fan. We were running an experiment. That's why it's happening. And I'm cranking up the fan. I can't even crank it up. So these things can go multiple times so that it works. This is the exhaust, this is the mixer, and that is the inlet. You can set the things based on what you're doing, and there's a chamber which you can send somebody in there and try to put their hand down there and try to feel things. But because normally this system is very small, it doesn't get as high as you want. The first experiment that you need to normally run is the electric heating of the air, which is very simple. You just turn on the preheater, and you can set this temperature to anything you want. You can set it to 40, 32, whatever you want. If you turn it higher, it doesn't get warm higher, It's just a tool for you to use. Then all you need to do is install VDAS, pick up the system type from the manual, and then once you do that, you can set it from here into the experiments, depending on what you're doing, preheating or reheating. If you want, you can turn on the reheater as well. You can see that the temperature is going up quickly. And if you set the reheater on, it also tries to turn on temperature. Anything that you turn on, their lights turn on when they are working. That is how it works. The room temperature was sitting around 21. And as you can see, this is just going higher. It reaches a point that it cannot go any higher. And the reason for that is that the coil is limited in its capabilities, right? One way to do it, to make that temperature to go higher, is bringing down the speed. And by bringing down speed, that temperature starts rising and going faster. As you can see now, it's moving and moving a little bit faster than it was because now the airflow is slower and it goes through the coil. So it gets warmer because the speed is lower. That is the first experiment that you need to do. Never bring the system to hard stop. Try to go and reverse it step by step. The next one that we do is we're doing the cooling one, the air cooling, experiment number 3. We asked the student groups to set the experiment to number 3. As you can see here, we have an air cooling. And once you do that, there's like a new tab opening based on what you need. So anything they change, these numbers change. And based on the manual, you need to read different numbers in order to solve. And those numbers should be recorded based on what you have. Once you do that, this one, you need to turn on the water chiller first. We're running an experiment. We're setting it at 8. So the water chiller is already at 8 and it's cooled enough. And for cooling, you need to water to air heat exchanger. And as you can see, that is where the exchanger is. And there's a schematic there, which we're going to go through quickly. You turn on the water heat exchanger. Once you turn it on, there's a noise going on. But you can see that how it works. When the system is turned on and it starts working. Depending on the speed, you can see that temperature is quickly dropping based on that water chiller. You ask the students to set different things that they want. This is probably one of the noisiest experiments ever. The other option, you have two cooling options with the system. One is water to air exchanger, one is evaporative cooling. This is water to heat exchanger, and it's working, and you see that the temperature is dropping and temperature is going down really fast. And now this is almost an equilibrium. Before reading any numbers, you need to let the system to reach an equilibrium. And here are the numbers. You see that they are changing. What you need to do is I'm going to turn the system on. This is for water to heat exchanger. There's the experiment of evaporative cooling in the experiments. And these are all step by step in the manual guide. I'm just following the steps here quickly. And for this system to run, you can pause it. We can let it run. And you can also do the evaporative cooling now. So you can see when I say to evaporative cooling, we don't need some of those and things change. For evaporative cooling, you still need the water chiller to be going down. And this time, instead of that, you turn on the evaporative cooling. Once you do evaporative cooling, you can see that water is being sprayed here. And that makes evaporative cooling makes our temperature to go down as well, because it's a cooling system, right? Evaporative cooling is like wet bulb and dry bulb temperature when you have the thermometer and you put a cloth around the bulb in the thermometer, and that absorbs the heat from the bulb and gives it to the environment. Evaporative cooling is almost the same idea. The water is sprayed. The spray here might not be the optimum, but it's a nice smooth spray that you can work. As you can see, it's also nice sprayed here. Before the system works. That is evaporative cooling. I'm going to turn it off. I'm going to turn the water chiller off. You can read some numbers here, refrigeration, dock temperature, and those information. Those information are also available on the VDAS system. And here's the schematic. The next example that we are going to use is air mixing. As you can see, there is 3 sensors here. This is sensor 1 in here, sensor 8 and sensor 9. And what you're doing, we're going to bring back the air and mix it. And that is how air mixing works, right? And then you will notice that there's a difference in temperature for the two. So air mixing is number 5. And all you need to do is to set this middle one, instead of shut, you can set it to fully open. So you need to take this thing out and just turn it to the desired damper size that you want. You can adjust the other dampers based on the air mixing that you want to happen. And then this one is also, again, the example is with the preheater. So you turn on the preheater, the temperature goes up. You can see that how the temperature is working. It's going up. The temperature here is also going up. You can cross-reference them. And the temperature damper is going up as well. And for this example, you need to record 3 velocities, V1, V2, and V3, air velocity 1, air velocity 2, air velocity 3. But as you can see, those are named V1 to V3, whereas the sensors here are 1, 8 to 9, right? So that is a little bit of confusing. So what you need to do is to remember to assign which air velocity you gave to which sensor. This is the sensor number. And if you assign air velocity 1 to sensor number 1, you need to remember that sensor number 1 is here, right? It is after the mixing. The mixer itself is 8 and 9 is the inlet, right? And what you need is you need to read those numbers. We just ran this example. The numbers are going to be a little bit different, especially if you set this very high to something like 25, 28 degrees. And then you will see how the air mixing works. It's just a fan, mixes the air completely. Based on air categories that you have in the building, in your building, you can sometimes recirculate air back to the room, but in majority of cases you can't, and you need to either treat it like ultraviolet lighting or filters, or you just can't do it if it's like highly toxic area, like a lab or something, like a chemical lab chemical lab or something. So for this example, the air is mixing directly. It goes in. You can check those temperature, especially temperature 1 and temperature 9 and temperature 8. Comparing 9 to 1 should have a difference. In our example that we just read, we had a 1 minute example, and that is how the air mixing works for this tool. So if you go to T1, that you can see here, is at 27, right? And then you have 9, 1 versus 9, which in here you have it at, I need to find T9 first. Oh, we forgot to put it on adiabatic air mixing. So when we do that, we will have T9 here. You can see that T9, the inlet air, is sitting at 2, and T1 is sitting at 27. That means that the mixing is being done very well, right? And T1 is right before the preheater, right? So it doesn't really impact it. Those are the examples. I'm going to turn this off. The last example is the humidifier. We can then turn the humidifier on. You need to turn it up, but be careful. The water should never be boiling, so a little bit of steam is more than enough to run this experiment. And the experiment we are doing is humidification. You need to set it in the tool. You can see that the tabs change based on what you set, there. And once you do this, you need to make sure that the water level is okay, otherwise it won't turn on. Same with the water chiller, you need the water level. And you need to be sure what you're doing. So this should be green. And how do you refill that? There's that small thing there, as you can see. When you are filling it with water, you should fill it to a level that the indicator there, it's a little bit below the indicator. And this should turn green. And when that happens, it means that the water level is good. This one should turn green, not this one. This one turns green, and it means that it's good. How do you pull the water there? There's deionized water there. You should not put regular water in it. You should put deionized water in it. What you do is that you open this. And you can just feel the water in here. And if you have a fan going on, you can feel that the air speed in here because the air comes out. Once you fill it with water that we already did for the experiment that we were running, after that, just wait. There will be some bubbles. That's how you know that there will be some steam coming out. You will see that there will be like fog forming on the glass, on the protective shield. You can see different things here. You can, while we're waiting for that to warm up, you can see the flow straightener here. I think this is a cool thing to show the students if you're using this tool. That is a flow straightener right there. That is working with the filters and how things are working. You can see that how different stuff are working. You can see the duct. Some students are also curious and they like to look into the duct itself and see what's going on. But that is for humidifier. While we're waiting for it to warm up, I'm going to close this and put it to fully shut. While we're waiting for this, I'm going to put it away. So just to show you one example, for example, we go to page 91 of how are things working. You have clean procedures. The aim, what is it like, what you want to do. The procedure is very clean, how to turn everything on, how to connect the VDAS. For any of those, you need to go to different pages if you don't know them, but I will show you how this is done. It tells you how long you need normally to wait, what to record, very simple, very easy, and how to use it. There's like some notes and stuff sometimes in the back page, but The procedure is up to here normally, on the first page, and it tells you exactly step by step what to do and how to run the system. This is the system that we're using, EC1550V. That's what we set up here. Something to remember about this tool is that you need to always press the small volume run here if you're letting it to record. So if you just open it, nothing is running, you need to press this so that it starts running and recording everything. We're still waiting for the humidifier to warm up the water for us. It normally takes time. Something I recommend is that when you want to do the humidifier example, try to turn it on in like a little bit earlier, like when you're doing other experiments. Try to turn it on so that the water warms up, because it normally takes 20 minutes, 30 minutes to just warm up the water. Sometimes it's slower, but the water was a little bit warm in our case, and as you can see the fog on the screen. Well, it's not happening because it's not warm enough, but it's getting there at some point. Still waiting for it. So this is the overall thing, and you have different systems here. You're doing the steam humidifier, you have the fan, you have the heater, you have the filter, you have all these filters going back and forth, shows the direction of the airflow, the chiller system down, and I think it's a very cool tool to demonstrate to students how different things are. I really like it. You can set the dampers. When you turn the system on, make sure that there's like the dampers are in the right position. The two are fully open and probably no mixing happening. And here we are still waiting for this. I'm going to turn the speed a little bit up or turn the speed a little bit down. See, there's like a small ones happening. I don't know if you can see it or not, but there's like a small fog forming on the screen. Just give it a few more minutes. Something fun that the students love is about this chamber. You can get in there and try it. So if you open it slowly, just be careful with these tools. You have the exhaust, you have the inlet. You can ask the students to put their hands here to see how this works. It's a very cool tool. There's also a chamber sensor there that measures everything for the chamber, which is T7 and relative humidity. And always remember that for the velocity thing, you need to put the sensors for the tool to work. This is the overall tool. Right now, this is at Carleton University. We normally do it for indoor air quality example. And I think it's really interesting to have these tools for students, because students really love working with these things, especially when they're learning something new. And always make sure that the students learn the engineering procedures by looking at the schematics, looking at the user guides, how to use user guides, how to run an experiment, how to do things as an engineering students or even as an architecture students. We have sometimes architecture students coming in. I study architecture myself, but I think it's a very interesting and very cool tool for everybody to learn. Now I'm seeing the fog slowly shaping here. Turning on the fan a little bit, you can see how the fog is forming. And once as the water gets warmer, the fogs become more clear or small on the glass. So you have two sensors which you can measure the temperature here and the relative humidity here and here. You can compare the two and see how that works. So relative humidity number 2 versus relative humidity number 3. By comparing those, you will learn that what the differences are in relative humidity for us. fog is even more clear now. I don't know if you guys can see it or not. It's just moving around, you know, it's like not constant, so you need to wait to capture it in the right moment. The difference in noise is because of the fan. I'm turning the fan speed on like more lower and higher, and that might give us an opportunity to capture it. And you can see it on the side of the screen, bottom left, and that is the experiment. I'm going to zoom in a little bit, and thank you so much for listening. There you go. Those are what's happening. Thank you so much for watching, and I hope you get one of these for your students and you enjoy. To turn it off, make sure that I turn everything off first. Everything is off, everything is off. Make sure the fan is off. And once that's done, you just turn it and you're done.